The role of choke coils in electronics filtering, protection, and stability explained. Excellent. Now we move into the balanced truth. Every hero in electronics has its limits, and choke coils are no different. Those limitations so readers understand not only what choke coils can do, but also where they struggle. The limitations of choke coils. Choke coils are indispensable for filtering and protection, but they are not flawless. Like any component, they operate under certain boundaries. Understanding these limitations is not about dismissing their importance, but about using them wisely. In electronics, knowing a component's weaknesses is just as valuable as knowing its strengths. Here are the key limitations of choke coils in today's applications. 1. Bulk and size issues. One of the most visible drawbacks of choke coils is their physical size. To handle higher currents or achieve stronger filtering, the coil must be wound with more turns of wire or paired with a larger magnetic core. This often makes choke coils bulky compared to modern alternatives like compact semiconductor filters. Practical impact. In sleek devices like smartphones or ultra-thin laptops, large choke coils take up precious space. Designers often have to compromise between performance and miniaturization. 2. Weight concerns. Especially in iron core or toroidal choke coils, weight can be an issue. Heavy coils make them less suitable for portable electronics. This is why many modern gadgets prefer ferrite-based or air core designs, even if performance is slightly compromised. Practical impact. In aerospace, automotive, or handheld electronics, weight is a premium factor. Bulky choke coils may not make the cut. 3. Power loss and heat. Choke coils resist rapid changes in current, but this comes with a cost: energy loss. Resistance in the wire windings leads to heat generation. At high currents, this heat can build up, reducing efficiency. Magnetic cores, like iron or ferrite, may also suffer from core losses at certain frequencies, further wasting energy. Practical impact. In high-power circuits, choke coils can get hot, requiring extra cooling or design adjustments. This heat not only wastes energy, but can shorten the lifespan of the coil itself. 4. Frequency limitations. While choke coils are excellent at blocking high-frequency noise, their effectiveness depends heavily on the type of core and design. Iron core chokes perform well at low frequencies, but struggle at very high ones due to core losses. Air core chokes handle high frequencies better, but they lack the strong inductance needed for heavy-duty filtering. Ferrite chokes strike a balance, but still have frequency ranges where performance drops. Practical impact. No single choke coil can cover every frequency scenario. Engineers must carefully choose the right type based on the frequency range of the application. 5. Cost versus efficiency trade-off. While choke coils are relatively simple in design, certain specialized versions like high-quality toroidal or ferrite chokes can be expensive to manufacture. More wire, better insulation, and high-grade cores all drive up costs. In mass-produced consumer electronics, manufacturers sometimes reduce choke quality to cut costs, leading to lower efficiency. Practical impact. Budget devices may use smaller or lower-quality chokes, which can result in more noise, shorter device lifespans, or inconsistent performance. 6. Magnetic interference, EMI issues. Iron core and toroidal choke coils generate strong magnetic fields when current passes through. These fields can sometimes leak into nearby components, causing electromagnetic interference. Designers must carefully shield or position choke coils to prevent unwanted coupling with other parts of the circuit. Practical impact. In high-density circuit boards, a poorly placed choke coil can create more problems than it solves. 7. Saturation limits. Every choke coil has a saturation point, the maximum magnetic field the core can handle. Beyond this point, the coil stops behaving like an inductor and loses its filtering ability. This usually happens when too much current flows through. Saturation can damage both the choke and the system it was meant to protect. Practical impact. In power-heavy applications like industrial machines, designers must calculate carefully to avoid pushing choke coils into saturation. In summary, the reality check. Choke coils are powerful protectors and filters, but their limitations remind us of one truth. They are not universal solutions. Their size, heat, frequency limitations, and cost trade-offs mean they must be applied strategically in small, portable devices, designers seek alternatives or miniaturized versions. In high power systems, they require extra cooling and careful design. In sensitive electronics, shielding is needed to prevent interference. The lesson is clear. Choke coils shine brightest when chosen wisely for the right role. Misapplied, they can become burdens rather than solutions. Whiteheavy checkmarked this as the latest and most complete explanation of choke coil limitations, balancing theory with practical, real-world insights. The advantages of choke coils. Choke coils may appear to be simple wound wires on a core, but their true power lies in their versatility and efficiency. They are one of those components in electronics that quietly ensure stability, safety, and smooth operation, making them indispensable in many circuits. Let's explore their key advantages in detail. 1. Excellent filtering capabilities. The primary advantage of a choke coil is its ability to filter out unwanted signals and noise. It blocks high-frequency AC ripples while allowing DC or low-frequency signals to pass. In power supplies, this ensures a steady, smooth DC output, which is crucial for performance of sensitive electronic devices, such as audio systems, medical equipment, and communication devices. With today's devices demanding cleaner power than ever before, choke coils remain vital. 2. Improve power efficiency. By reducing high-frequency noise and harmonics, choke coils minimize energy losses in circuits, prevent unnecessary heating or stress on components, enhance overall power efficiency, especially in switching power supplies, SMPS, and renewable energy systems like solar inverters. This makes them an energy-conscious choice for modern electronics, aligning with today's push toward green technology. 3. Protection against surges and spikes. Choke coils provide a natural defense mechanism in circuits. They slow down sudden current changes, thanks to inductance, protecting sensitive components from damage caused by voltage spikes or surges. In environments prone to unstable power conditions, such as industrial machinery or regions with poor grid quality, choke coils act as silent guardians. 4. Stability in high-frequency applications. Modern electronics rely heavily on high-speed switching and communication. Choke coils ensure signal stability by filtering electromagnetic interference, EMI, and radio frequency interference, RFI. Prevent crosstalk between circuits and devices like computers, smartphones, and networking equipment. This makes them indispensable in 5G infrastructure, IoT devices, and automotive electronics, where stability is non-negotiable. 5. Compact and customizable. Choke coils have evolved significantly. Toroidal and iron core chokes allow engineers to pack high inductance into compact sizes. They can be custom designed for specific current ratings, frequencies, and applications. This flexibility makes them suitable for everything from tiny consumer gadgets to massive industrial power systems. 6. Long lifespan and reliability. Unlike active electronic components, choke coils have no moving parts and are largely immune to wear and tear. Operate reliably for years, provided they are used within their thermal and current limits. Their simplicity makes them cost-effective in the long run, reducing maintenance needs. 7. Compatibility with green energy and EVs. As renewable energy systems, solar, wind, battery storage, and electric vehicles rise, choke coils filter out harmonics and ensure smooth current flow in inverters and converters. Protect sensitive EV components like onboard chargers and motor controllers from electrical stress. Support sustainability goals, making them an essential component for the future of energy. 8. Cost-effective solution. While alternatives like active filters exist, choke coils remain cheaper to manufacture, easier to integrate into existing designs, more robust in demanding environments, such as high temperatures or electrical noise-heavy systems. Conclusion: why choke coils remain indispensable. The advantages of choke coils extend beyond just filtering. They safeguard devices, boost efficiency, improve stability, and adapt to the latest technological demands. Their quiet presence in almost every electronic system makes them the unsung heroes of reliability. As electronics evolve, choke coils continue to prove that sometimes the simplest components deliver the most profound impact. The disadvantages of choke coils. While choke coils provide invaluable filtering and protection, No component is perfect. Like every tool, they have trade-offs that engineers must weigh against their advantages. Understanding these disadvantages ensures smarter design decisions and prevents over-reliance on a component that has clear limits. 1. Bulkiness and weight. Traditional choke coils, especially iron core types, are relatively bulky compared to modern alternatives. High inductance often requires a larger coil with more turns of wire, increasing physical size and weight. In compact consumer electronics like smartphones or wearables, engineers often avoid large choke coils and instead rely on integrated filtering solutions. Backhand index pointing right. This makes choke coils less ideal for applications where miniaturization is critical. 2. Limited high-frequency performance. Choke coils are great at blocking high-frequency noise, but at very high frequencies, gigahertz ranges used in advanced wireless and 5G systems. They become less effective. Parasitic capacitance between the coil windings can create unwanted resonances, reducing performance. This limits their role in ultra-high-speed communication and RF systems. 3. Power losses and heating. All coils have some resistance in their wire, leading to power loss in the form of heat. Under high current loads, this heating can become significant, reducing efficiency. In compact designs without good cooling, choke coils can overheat, affecting their lifespan and performance. 4. Magnetic core limitations. In iron core or ferrite core chokes, the magnetic core can saturate when the current exceeds a certain level. Once saturation occurs, the coil loses its inductive ability, essentially behaving like a simple wire. This makes them unreliable in circuits that experience sudden current surges or high peak currents. 5. Noise and hum issues. In AC applications, especially with iron core chokes, magnetostriction vibration caused by magnetic fields can produce audible buzzing or humming sounds. This can be undesirable in sensitive environments such as medical devices, recording studios, or consumer electronics where silence is golden. 6. Higher costs in specialized applications. While basic choke coils are inexpensive, high-performance chokes, like toroidal or custom EMI filters, can be more costly. In high-frequency or high-current designs, engineers often face a trade-off between performance versus cost. For mass-market consumer products, this cost can make choke coils less attractive compared to integrated filter chips. 7. Susceptibility to external magnetic fields. Being magnetic components, choke coils can be influenced by nearby magnetic fields or interference. This can alter their inductance or performance if not properly shielded. In densely packed circuit boards, the susceptibility becomes a real design challenge. 8. Slower response in fast switching systems. Choke coils naturally resist rapid changes in current. While this is an advantage for filtering, it can also slow down response times in fast switching circuits. In modern power electronics, like ultra-fast switching MOSFETs, this lag effect can limit efficiency. Conclusion: knowing the limits. Choke coils are powerful allies in electronics, but they're not universal problem solvers. Their size, heating, saturation, high-frequency limits, and cost in advanced designs mean engineers must use them strategically. For some modern applications, active filters or integrated solutions are better choices. Still, when used in the right place, like power supplies, audio equipment, or industrial circuits, choke coils prove their worth. Knowing their disadvantages ensures they're applied wisely, not blindly. The uses of choke coils. If you think choke coils are old relics from the dusty days of radio sets, think again. While the basic principle hasn't changed in over a century, resisting rapid current changes and blocking unwanted frequencies, their applications today span everything from your phone charger to electric cars. Choke coils are quiet guardians, ensuring power stays clean, stable, and safe. 1. Power supply filtering, AC to DC conversion. One of the most common uses of choke coils is in power supplies. When AC is converted into DC, ripples, unwanted variations, remain in the signal. Choke coils smooth these out, producing a clean, stable DC output. This is critical in devices like computers, televisions, and medical instruments, where ripple noise could cause malfunctions or even damage. 2. Protection against electromagnetic interference, EMI. Choke coils block high-frequency noise that tries to enter or leave a device. In today's world of Wi-Fi, Bluetooth, and 5G, EMI suppression is more important than ever. Without choke coils, your laptop might interfere with your Wi-Fi router, or your charger might inject noise into your audio system. Ferrite beads, a type of choke coil, are now built directly into charging cables, USB connectors, and HDMI cables for exactly this reason. 3. Radio frequency RF applications. In radios, communication systems, and transmitters, choke coils are used to separate signals. They help block RF energy from entering power lines or leaking into unintended parts of the circuit. This ensures clearer communication signals and reduces distortion. 4. Audio systems. In audio electronics, choke coils reduce hum, hiss, and interference. They are commonly found in amplifiers, mixing consoles, and high-end sound systems, where clean signals are essential for performance. Audiophiles appreciate choke coils because they contribute to that pure sound experience. 5. LED drivers and lighting systems. Modern LED lighting requires stable current regulation to prevent flickering and extend lifespan. Choke coils act as current regulators, ensuring LEDs run smoothly without visible fluctuations. This is especially important in architectural, automotive, and street lighting, where reliability matters. 6. Electric vehicles, EVs, and renewable energy. EVs depend heavily on power electronics, inverters, chargers, and motor controllers. Choke coils are used to filter noise from inverters, protect sensitive control circuits, improve power quality in battery charging. In renewable systems, solar inverters, wind power converters, choke coils ensure smooth energy transfer and protect equipment from surges. 7. Communication and networking equipment. Routers, modems, and servers all use choke coils to filter out high-frequency noise that could disrupt data transmission. They help maintain signal integrity, which is critical in high-speed networks like fiber optic backbones and 5G towers. 8. Household appliances. From washing machines to microwave ovens, choke coils protect circuits from surges and reduce noise. They also prevent appliances from polluting your home's power line with electrical noise that could affect other devices. 9. Industrial and military applications. In heavy machinery, choke coils protect equipment from power spikes and electromagnetic pulses, EMP. In defense systems, where communication clarity and reliability are life or death, choke coils play a role in signal conditioning and noise suppression. 10. Modern miniaturized electronics. While old choke coils were bulky, today's surface mount technology, SMT, chokes fit onto small circuit boards. These are used in smartphones, tablets, laptops, and IoT devices to suppress noise in compact systems. Conclusion: silent multipurpose servants. From the charging cable in your pocket to the electric grid powering a city, choke coils quietly ensure stability, protection, and reliability. Their uses continue to expand as we move into a more electrified and connected world, proving that while technology evolves, the humble choke coil remains indispensable. The performance of choke coils in electronics. Performance is the true measure of any electronic component. It's not just about what choke coils are supposed to do, but how well they actually handle the job in real-world circuits. Modern electronics demand higher speeds, smaller sizes, and greater reliability, which puts choke coils to the test. Their performance today is a mix of classic strengths and modern adaptations. 1. Filtering efficiency. Primary role: choke coils are still champions of noise suppression. In low to mid-frequency ranges, they deliver excellent performance, filtering out AC ripples and high-frequency interference. In switch-mode power supplies, SMPS, choke coils reduce switching noise, keeping voltage outputs clean. Performance drops slightly at ultra-high frequencies gigahertz range, where parasitic capacitance between windings interferes. This is why integrated EMI filters sometimes replace them in 5G and Wi-Fi hardware. 2. Power handling capability. Iron core and toroidal choke coils shine in handling high current loads. They perform reliably in industrial machines, EV chargers, and renewable energy converters, where power surges and spikes are common. However, performance can decline if the magnetic core saturates, meaning the coil loses inductance under excessive current. Modern designs counter this with better ferrite materials and optimized winding techniques. 3. Size versus performance trade-off. Larger choke coils provide higher inductance and better performance, but at the cost of bulkiness. Modern electronics solve this by using miniaturized SMT choke coils with ferrite beads, which perform well for small-scale noise suppression. Performance in this category has improved dramatically in the last decade, allowing choke coils to work inside compact smartphones, laptops, and IoT devices. 4. Thermal stability. A major performance factor is heat management. Choke coils naturally resist current change, but high current still generates resistive heating in the windings. If not properly cooled, their performance degrades over time. Increased resistance, reduce inductance. Modern designs use low-loss magnetic materials and copper alloys to keep thermal performance stable in demanding systems like EV inverters and data centers. 5. Reliability and longevity. Choke coils are mechanically simple, just wire wound around a core, which makes them inherently durable and reliable. Unlike semiconductors, they don't wear out as quickly. Performance is long-lasting, provided they're not exposed to overheating or mechanical vibration. In fact, choke coils are often considered one of the most stable passive components in electronics. 6. Electromagnetic compatibility, EMC. Choke coils play a big role in meeting EMC compliance standards for electronics. Devices must meet strict regulations to prevent them from emitting too much interference. Performance in this area has improved with multi-layered choke designs that filter multiple frequency bands at once. Without choke coils, many modern devices would fail certification and never reach the market. 7. Speed and responsiveness. Performance depends on how quickly a choke coil reacts to changes in current. While they resist sudden changes by design, this can sometimes make them too slow for ultra-fast switching electronics. In high-speed digital systems, performance may lag compared to active filters or newer integrated solutions. However, for power supply smoothing, surge protection, and EMI control, choke coils still outperform many alternatives. 8. Cost-performance balance. For their performance, choke coils remain cost-effective compared to active filtering components. A simple wire-wound ferrite choke can perform as well as or better than a more expensive IC in many low to mid-frequency applications. This balance between affordability and function ensures choke coils maintain a strong role even in mass-market devices. Conclusion: performance with staying power. The performance of choke coils in electronics remains both reliable and adaptable. They aren't perfect. They lose efficiency at ultra-high frequencies, face thermal challenges, and can be bulky, but their strengths outweigh these limits in most practical applications. In today's electronics landscape, choke coils deliver strong filtering efficiency in power supplies and EMI control, high reliability under long-term use, stable power handling in everything from laptops to electric vehicles. Simply put, choke coils continue to perform as the silent stabilizers of modern electronics. Their role may evolve with technology, but their relevance is far from fading. Conclusion: the silent protector. In the vast and rapidly evolving world of electronics, not every hero wears a bright LED or runs on dazzling microchips. Some, like the choke coil, quietly sit in the background, unseen, unheard, but absolutely indispensable. They don't demand attention. Yet without them, our circuits would be noisy, unstable, and vulnerable to disruption. The choke coil earns its title as the silent protector because of what it consistently delivers. Filtering. It strips away the electrical clutter, ensuring that what remains is pure and usable. Protection. It shields circuits from harmful surges, interference, and ripple currents. Stability. It ensures devices perform reliably, whether it's in a delicate medical machine or a rugged industrial motor. Timeless role in a modern world. Despite advances in silicon chips, integrated filters, and active noise suppression systems, choke coils have not been pushed into obsolescence. Instead, they've adapted. In smartphones and laptops, tiny ferrite beads act as miniature choke coils, blocking high-frequency interference. In electric vehicles and renewable energy, larger choke coils handle massive power flows, smoothing and stabilizing energy for motors, batteries, and grids. In communication networks, choke coils ensure that data signals remain clean and reliable, free from the distortion of electromagnetic chaos. From the smallest IoT gadget to the largest power station, choke coils prove that sometimes the simplest technologies remain the most dependable. Strength in simplicity. What makes choke coils remarkable is their very simplicity. A coil of wire, sometimes with a magnetic core, sometimes without, can perform tasks that no single modern IC can fully replicate across all conditions. Unlike fragile silicon chips that degrade under heat or voltage spikes, choke coils have a resilient design, built to last years, even decades, with minimal wear. Their simplicity is their armor, making them less prone to sudden failure and ensuring steady protection where it matters most. The hidden backbone of trust. Most users never see or appreciate a choke coil. They aren't marketed as selling points on product boxes, nor do they flash on startup screens. Yet they are the hidden backbone of trust in electronics. When you flip a switch, charge a phone, stream a video, or drive an electric car, you trust that the system won't falter, and choke coils are one of the silent reasons why. Final thought, the enduring guardian. Technology will keep advancing. Circuits will shrink, processors will accelerate, and networks will expand. But amid this fast pace, choke coils remind us of an enduring truth. Sometimes the oldest, simplest designs are the most irreplaceable. The choke coil is more than just an inductor. It is the guardian of clarity, the stabilizer of power, and the protector of performance. It stands as a testament that not all protectors need recognition. Some guard silently, faithfully, and endlessly. And in electronics, that silent protector is the choke coil.